This is Mr. Pillar for ECET273 Modern Energy, lecture number 12. This is the beginning of our power plant discussions, and we're going to begin with one that I know fairly well, the Purdue University Wade Power Plant. This is the power plant on Purdue's main campus in West Lafayette. You're going to see everything that it provides for all of campus. It allows campus to be its own city, essentially. The Chapter 6 of Square 9 of DeWitt text talks about generators, so that is part of the pertinence of this lecture. Units 3, 4, and 5 of the Fardo-Patrick text are all topics that will be covered in this lecture also. I also want to give Brandon Stevens of the Purdue University Utilities Engineering, he gave this presentation originally to my class, and I have used the information multiple times, and now it's in this presentation view, so I want to give him credit for all of that information too. Thank you, Brandon. Alright, here's a picture of the Wade Power Plant. If you've been to main campus in West Lafayette, you probably haven't seen this view. This is from the south looking north. You probably have seen just the flat side on the north looking south. This tube here is the coal chute. Off to our right would be a large, the large bunker of coal that the trucks deliver coal daily to. That travels up here to the top, and all of the coal-fired boilers are fed from the top, and they utilize gravity, feed it in, and drop down the ash and all the way through, and then they'll truck the ash out on the bottom. Alright, the utilities network at Purdue University comprises of a few things. Wade Power Plant is the heart of their system. There is electrical power distribution, there's steam distribution, chilled water distribution, compressed air distribution, and then they have the other portions that they're responsible for, the potable drinking water, sewer issues, data phone, security, and gas distribution. Let's begin here at the very beginning. Wade was originally built in 1961. It had two boilers, boiler 1 and boiler 2. Boiler 1 is a spreader stroker coal unit. The coal enters from the mechanical belts at the top, and it's slung into the firebox. So imagine just throwing pieces of coal into the air. Currently in operation, will be decommissioned in 2012. So it's actually still probably in the process of being decommissioned now, and it is 2013 February. Boiler number 2, spreader stoker coal unit, enters boiler via mechanical belts, and it's slung into the firebox also. So what do we mean by that? There's fingers that are in every other position along a belt that are throwing coal into the air. It actually ignites in the air and burns mostly before it hits the ground. When it hits, by the time the coal hits the very bottom of the firebox, it's already ash at that point. Each boiler 1 and boiler 2 have a capacity of 200,000 pounds of steam per hour. Operates at 650 psig at 825 degrees Fahrenheit. Each unit at full load can use 300 tons of coal a day. A semi-truck usually handles 25 tons of coal, so that means 12 truck loads per day per boiler. I want to also make note that this coal is actually Indiana coal. There is no coal that comes from anywhere but southern Indiana out of it to fire these boilers. Here's a photo of boiler number 1. Looks big, old, and mean. Right here, you can, if we were there physically, we could open up these doors and see the fire going on. This is where the coal gets fed in. Then it goes to the very back and gets flung forward. As you look inside here, there's tank treads. Essentially, there's a big, large conveyor belt that has air blowing up in it to provide air for the combustion, and that tank tread has an ash bed that's then getting pulled to the back to get dumped again. And number 2, same kind of look, same kind of design. Basically both boiler 1 and boiler 2 are essentially the same designs. Boiler 3 is an oil and gas fired. It can go by either fuel. Its capacity is also 200,000 pounds of steam. It operates at 650 psig, but at a lower temperature of 650 degrees Fahrenheit. It's designed for number 2 fuel oil. At full load, it'll take 39 gallons a minute. That means 936 gallons are used in 24 hours. Natural gas delivered to burners at 15 psi. There's 300,000 cubic feet per hour at full load. The difference between the two, they added the burners later. It was originally designed for the fuel oil. They added the gas burners later. Boiler number 5. This is a very interesting boiler. It's the only one in the state of Indiana. It's called a fluidized bed. Let's hit its specs real quick. Again, 200,000 pounds of steam per hour. Reaches the 650 psig. That's the header of the entire system. 810 degrees Fahrenheit. It takes crushed, air-swept coal stoked. We'll talk about what that means in a second. And it also takes limestone. Look here, 300 tons of coal a day, 108 tons of limestone. So what this is doing, they add in crushed coal and crushed limestone into this firebox, and they spin it with air jets, and it gets spinning basically in a liquid fire burning in a circle in the bottom of this. We can't look inside of this firebox like we could in 1 and 2 because it's just too darn hot, and it spins in there. What the limestone does is it grabs a hold of the sulfurs and the nitrates and pulls all that out into the ash, so it doesn't go up into the air out of the smokestack. And here's a picture of it. It insets down here. The firebox is actually down in this set here. Here is your exhaust gas. There's the most. That's the steam. That's where the steam. All those pipes is the water that's going in there. But down in here is the actual fuel. The fuel fire. Boiler number 7 is a gas boiler, and it's being installed. It's been installed already. It has, again, 200,000 pounds of steam per hour and operates at 650 psig, 825 degrees Fahrenheit. This came in on a train. This is actually there on the tracks right behind WadePowerPlant. They opened up the side of the building and they put this puppy in. It looks like it's essentially a giant gen set that you'd see running a hospital or some such like that. And here it is partially installed. Like I said, I've seen I've seen this is all finished off and it's been fired and it's up and running now as we speak. But this is the installation phase. So now we ask the question, what happened to boiler 4 and boiler number 6? I guess we're engineers, but we can't count very well. Well, boiler number 4 was removed after it reached its end of life, and boiler number 6 was never installed. It was a project that was canceled in 2011. That boiler would have been a fluidized bed like boiler 5. There was some litigation about using coal boiler on Purdue's campus, and for the end of that litigation, we ended up having to purchase a gas fire and canceling everything we had with the fluidized bed. And so that's why we now have boiler 7 and not boiler 6. Why didn't they change the names just so they could have 1, 2, 3, 4, 5, 6? All the drawings and all the mechanical drawings, all the electrical drawings refer to each number. So any pipe that's there that hasn't been fully removed would be labeled for boiler 4 or for boiler 6, any pre-work that was done for that. And so we don't want any of that confusion to be going, so you just continue to add up your names. So I thought steam was primarily used to generate electricity. Well, WadePowerPlant really generates steam to heat and cool the campus buildings. The generation of electricity is produced. It's just an extra on top of the the cost of heating and cooling campus buildings, and we call that cogeneration. We have the capacity to generate 30 to 50% of the electricity to run campus at the Wade power plant. Since we don't have the capacity to produce all the electricity needed on campus, we have to buy power from Duke. Duke is the local electrical supplier, like in South Bend would be AEP. Duke is the local there in West Lafayette. They have two substations, separate lines at each so that they can buy power from. They have a substation north, substation south. South has 2 lines coming in, north has 3 lines coming in, so you could select which one is, well, Duke would select which line we are drawing power off. They have SEL protective relays. SEL is the company that manages, that we purchase the relays from, and they're all SCADA controlled. That's supervisory control and data acquisition. That's what SCADA stands for. Here is the south power substation. Right there, that trailer there is all the circuit breakers, the SEL protective relays that run off the campus underground. Incoming line comes in here, comes across here, goes into these transformers and reduced down to our campus transmission voltages. So, as you noticed, steam is produced at 650 psig, 825 degrees Fahrenheit, using the boilers in the plant. The high pressure steam is then run through turbine generator number 1 and generates up to 300 megawatts of power for campus. The exhaust of that generator is 125 psig. Ironically enough, 125 psig is the pressure that we need to go to campus heating. That's the purpose of the generator. It's a voltage drop, right? It's like a giant resistor to the steam circuit. It drops the pressure across the turbine, and we get electricity because of that power exchange. Here's turbine generator number 1. In here you have, here's the turbine and here's the steam pressure. That's the actual generator right there. Steam is going up and through in all these pipes here. 30 megawatts, 14.47 kV coming off this. Steam exhausted from TG1 at 125 or 15, not only used for campus heating, but it can be used to drive 3 chillers that drive turbine motors and fans and feed pumps all across campus. 10 megawatt generator exhausts 125 psig, and that's used for campus heating, laboratory work, and cooking. They actually use this steam for cooking also. So we have 2 generators on campus. Here's the second generator. This is the original generator. Small, very small in comparison to generator 1. Generator 2 sits right here, and here's your steam. You can see the blankets maintain the heat on the steam and your mechanics. They do have a diesel generator that sits outside of Wade Power Plant. When Y2K came around, they weren't sure what was going to happen, and they had this diesel generator as a backup to protect themselves from Y2K. If all power was lost from the grid, you can't start Wade Power Plant up from black. So they call this the black start generator. They would go out, they would get this thing dieseled up. This thing would already have diesel in it, get it up and running, and give them 2 megawatts of power to start powering up all the feed pumps and everything that needs to go into getting the boiler started, get water flowing. That's the big deal, right? The feed pumps, I've mentioned a few times here, feed pumps are what's moving water into the boiler. If water isn't moving into the boiler and the boiler is hot, the boiler melts. The water has to pull all that heat out and move it into steam. So we have to get feed pumps moving, and they're electrical. And if we have no power being supplied by ourselves or by outside power, ideally this diesel generator would do that. Steam is produced using water, which is constantly monitored. So in the steam that runs the equipment provides USDA approved steam for cooking on campus. So we need clean steam for 2 reasons. A, it's cooking things on campus, and so there's issues with that. And then also, when you're using steam to run through all those tubes, you need clean and pure water with no impurities so that it doesn't cause lime buildup and issues across the board there, which would eventually cause clogging and no water flow, and then that pipe melts, and then bad things will happen to your boiler if that goes down. 90% of the steam is recycled through the system. The rest is lost due to leaks. So this is a closed loop system. Everything that WadePowerPlant sends to campus, 90% of it comes back. This is a picture of the water quality lab. There's a gentleman that takes care of that water quality. He samples the condensate return to make sure there's no impurities.